All right, so let's talk about Isaac Newton here. And as you know, Isaac Newton had contributions to both math and science. And a fun fact is in 1665, shortly after he graduated from Cambridge with his Bachelor of Arts degree, his school was shut down due to the Great Plague. All right, who would have thought? But today we're going to talk about his Newton's three laws and Newton's law of gravitational attraction. So just quickly, Newton's first law is that a particle at rest, or it could be in motion, will remain in that state unless acted upon by an unbalanced force. Okay, so if we threw a ball up in the air, right? If we didn't have the unbalanced force of gravity, that ball would continue on forever, right? Okay, so the second law of Newton's is probably the one that you're most familiar with and the easiest to say, right? F equals the mass times acceleration, right? So it relates an unbalanced force. If a force is unbalanced, it relates it to its mass and its linear proportionality to acceleration. Okay, F equals ma. All right, and then Newton's third law here. Let's just demonstrate this one really quick. So if you're running like this, right? So if there is an mutual forces of action and reaction between two objects are equal. All right, they're opposite, collinear. So, for example, if you're running and you exert a force, let's say, of 200 pounds downward on the ground as you run, right, there is an equal and opposite force that's pushing 200 pounds upwards on your foot. All right, if that wasn't equal, your foot would go right through the ground, right? So, there's that relationship there. Okay, so that's the first, second, and third Newton's laws, but there's an additional law, which is Newton's law of gravitational attraction. Newton's law of gravitational attraction. Okay. All right, and let's write that. The force is equal to G m1 1 times m2 divided by r squared. Okay, so what's this mean? Well, any two objects have a force of attraction between them. I have a force of attraction between me and this microphone. It's just so small that I can't feel it, okay? But what we can feel is the force of attraction between us and the Earth, right? All right, so G is just is the universal constant. So that's the universal constant. So m1 is the mass of one object. So for example, that would be me. And m2 may be the mass of another object, which would be the Earth. And r squared, r is the distance between the two objects. So that may be the distance in between my center of gravity and the distance and to the center of the Earth's center of gravity there. And that is Newton's law, Newton's three laws and Newton's law of gravitational attraction.